Let's explore the topic of finding images depicting large-scale electrical installations, specifically focusing on Romex wiring and conduit runs. Unfortunately, a direct image search for a specific photo is not currently possible. However, we can explore alternative resources to potentially locate similar visual examples. One approach is to examine articles and online resources related to electrical contracting and installation. These often include photographs and illustrations showcasing various wiring methods and installations. We will be reviewing two online resources for the user. The first resource is a link to an article titled Massive Electrical Conduit Run, which is located at electricalcontractor.net. The second resource is a link to a Wikipedia article regarding electrical conduit, which may contain photos or visual representations of conduit installations. When examining installations of Romex, which is non-metallic sheath cable, there are some things that must be followed. Firstly, the National Electrical Code, or NEC, provides specific guidelines for the proper installation of Romex. These guidelines cover aspects such as support requirements, bundling limitations, and protection against physical damage. For example, NEC Section 334.30 addresses securing and supporting non-metallic sheath cable. It specifies the intervals at which the cable must be supported to prevent strain and maintain its integrity. Secondly, bundling of Romex cables can affect their ampacity, which is the current carrying capacity. When multiple cables are bundled together, the heat generated by each cable can raise the overall temperature, potentially exceeding the cable's insulation rating. NEC Section 310.15 and associated tables address ampacity adjustment factors for multiple conductors in a raceway or cable. It's crucial to consult these tables to ensure that the Romex cables are properly sized for the intended load and that the ampacity is adjusted accordingly for bundling. Thirdly, physical protection is another important consideration. Romex cables are susceptible to damage from nails, screws, and other objects. Therefore, NEC Section 334.15 outlines requirements for protecting cables where they pass through or are exposed to physical damage. This may involve using methods such as running the cable through conduit or installing protective plates. Electrical conduit, on the other hand, offers a robust and versatile solution for protecting electrical wiring. There are several types of conduit available, each with its own characteristics and applications. One type is rigid metal conduit, or RMC, which is a heavy-walled steel or aluminum conduit that provides excellent physical protection. RMC is typically used in harsh environments or where there is a high risk of damage. Another type is intermediate metal conduit, or IMC, which is similar to RMC but with a slightly thinner wall. IMC offers a good balance of protection and cost-effectiveness. Electrical metallic tubing, or IMT, is a thin-walled steel or aluminum conduit that is lightweight and easy to install. EMT is commonly used in commercial and residential applications where physical protection requirements are less stringent. Flexible metal conduit, or FMC, is a flexible conduit that allows for bending and movement. FMC is often used to connect equipment or appliances where flexibility is needed. Liquid-tight flexible metal conduit, or LFMC, is a flexible conduit with a liquid-tight jacket. LFMC is used in wet or damp locations to protect wiring from moisture. Conduit fill is an important consideration when installing wiring in conduit. NEC Chapter 9 Table 1 specifies the maximum allowable fill for different types of conduit. Exceeding the fill limits can make it difficult to pull wires and can also lead to overheating. When installing conduit, proper bending and joining techniques are essential. Bending conduit requires specialized tools, such as conduit benders, to avoid kinking or damaging the conduit. Conduit fittings, such as couplings and connectors, are used to join sections of conduit and to connect conduit to boxes and enclosures. Grounding is a critical safety requirement for electrical systems. Conduit systems must be properly grounded to provide a path for fault current in the event of a short circuit. NEC Section 250.118 specifies the acceptable methods for grounding conduit systems. These methods include using grounding bushings, grounding lock nuts, and grounding conductors. Support requirements for conduit are also outlined in the NEC. Conduit must be supported at intervals specified in NEC section 344.30 to prevent sagging and maintain its integrity. The support requirements vary depending on the type and size of conduit. In summary, finding images of specific electrical installations can be challenging, but exploring online resources and understanding the relevant electrical codes and standards can help in locating visual examples. Remember to always consult the NEC and local codes for specific requirements and to ensure that electrical work is performed safely and correctly. The NEC is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and best practices. Local codes may also have additional requirements that must be followed. When planning an electrical installation, it is important to carefully consider the load requirements, the wiring methods, and the protective devices. The load requirements will determine the size of the conductors and the overcurrent protection devices. The wiring methods will depend on the environment and the type of building. The protective devices, such as circuit breakers and fuses, are designed to protect the wiring and equipment from overloads and short circuits. Safety is paramount when working with electricity. Always disconnect the power before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician. This information is for general educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work. Here is some additional information regarding wire management that may be useful. When installing electrical wiring, it is important to manage the wires properly to ensure safety and reliability. Proper wire management involves several key considerations. One consideration is neatness. Neatly organized wiring is easier to troubleshoot and maintain. It also reduces the risk of accidental damage or shorts. Another consideration is support. Wires should be properly supported to prevent sagging and strain. This can be achieved using cable ties, straps, or other appropriate support methods. Thirdly, protection is important. Wires should be protected from physical damage, moisture, and other environmental factors. This can be achieved by using conduit, cable trays, or other protective measures. Furthermore, separation is key. Different types of wires, such as power and data cables, should be separated to prevent interference. This can be achieved by using separate conduit runs or cable trays. Identification is necessary. Wires should be clearly labeled to identify their function. This can be achieved using wire markers, tags, or color coding. Accessibility is also something to think about. Wires should be accessible for inspection and maintenance. This can be achieved by providing adequate access points and using removable covers. Finally, documentation is useful. A detailed wiring diagram should be created and maintained to facilitate troubleshooting and future modifications. Some common wire management techniques include bundling. Bundling wires together can help to keep them organized and prevent them from tangling. Cable ties, straps, and other bundling materials can be used to secure the wires. Another technique is using cable trays. Cable trays are open support structures that provide a convenient way to route and support multiple cables. Cable trays are commonly used in commercial and industrial applications. Another technique involves using conduit. Conduit provides a protective enclosure for wires, shielding them from physical damage and environmental factors. Conduit is available in a variety of materials and sizes. Furthermore, another technique involves using patch panels. Patch panels are used to organize and connect network cables. Patch panels provide a central point for managing network connections. Another popular technique is using wire ducts. Wire ducts are enclosed channels that provide a neat and organized way to route wires. Wire ducts are commonly used in control panels and other equipment enclosures. Finally, using labels helps with wire management. Labels are used to identify wires and their functions. Labels can be applied directly to the wires or to cable markers. Proper wire management is essential for ensuring the safety and reliability of electrical systems. By following these guidelines, you can create a neat, organized, and well-protected wiring installation. Remember to always consult the NEC and local codes for specific requirements and to ensure that electrical work is performed safely and correctly. The NEC provides detailed information on wire management practices, including requirements for support, protection, and separation of wires. Local codes may also have additional requirements that must be followed. When planning an electrical installation, it is important to carefully consider the wire management requirements and to select the appropriate materials and techniques. This will help to ensure that the wiring is properly organized, protected, and accessible for maintenance. Remember that this information is for general educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work.